Welcome back. It's me, Kayla Jones again. Now, I'm getting ready to do the fourth test experiment with the cloud chamber, but here's the catch. This time we ain't using no radiation, just dry ice and isopropyl alcohol. So, first, we take the alcohol and just put a little bit onto the baking tray. That's it. And then we spread it around like so. Then now we put the top on. Huh? Tape it up. Alright, and then now I'm going to tape it up again because we have to take the tape off in order to get the radiation sources out. I'm back, and now I've finished resetting up the cloud chamber, and look, as you can see, there is no rocks in here. So that means I'm going to test out my hypothesis. Here are my hypotheses. The more radiation is in the cloud chamber, the more activity will be. The less radiation there is, the less activity it will be. So now, let's turn out the lights and begin the show. Oh. I can see a little bit activity going on in there. Ooh. So, this is going on without no radiation. And I don't know how this is happening, but it seemed to be my hypothesis about the less radiation, the less activity. And I think there might be wrong, you guys. Cause I see
might be the same amount of activity.
It might just be the same, and like similar to with radiation. And so we're all learning something from this.
So that would lead me to believe that it's about the isopropyl alcohol, and
so that would lead me to believe that it's about the isopropyl alcohol and the dry ice working together to make these clashes, and then boom, you see these bent lines. Like, you don't see as many straight lines like you do with the radiation. You see like bent, curved, and decaying particles. You don't see a lot of decaying particles because when we did the radiation, it was a lot of straight line activity. Like, it wasn't as curvy as it was.
I see the little ones. I see the vapor. You see the little ones?
The vapor? Oh yeah, I see them. I can't believe you can actually see this through the phone. Because usually you can't see smoke through a phone.
It's because I'm standing still.
What are those bent ones called again?
I think those are the... It's neurons, the alpha something.
Alpha particles are the decaying ones.
Yeah, those are the little ones. It's a P one, I think it is. I can't remember the name of it.
So I don't know if you can see it, but I can see it about the decaying particles are called alpha particles. I'm not so sure why they're called alpha particles, but then they're called that for some reason. I I'm gonna try to figure out what is these curved lines that are slashing through the mist, and I'm trying to figure out what are the lines that go straight pow like that. So it looks like my hypothesis might have been wrong.
Oh,
They have been, because I did say that it was less radiation. But it's like almost the same amount or more, a little bit more. Because you didn't see no curved lines when we did the radiation.
maybe it just yields a different paths with the radiation.
They leave some radiation behind?
No, because we cleaned it. It's different paths from, the radiation gives it a whole nother, another charge inside of there.
Right. I can see more alpha particles.
Mm-hmm. I haven't seen any in the neurons yet.
Neurons?
The neurons.
Neurons? What's those?
The straight ones.
I did see like 3 of them.
I didn't see those. I see a lot of the curved ones, and I can't remember the name of those. I think they was a neutron.
Neutron?
Mm-hmm.
Give me neutron.
Okay.
It's still active. It's a lot more active than the radiation.
Okay. You ready to close out?
Mm-hmm. You just gotta see. So, I hope you guys enjoy this one right here, because it looks like that my hypothesis was wrong about less radiation. Like, it was a little bit more, but similar to when we had the radiation. But you didn't see as many straight lines like you did during radiation. You seen a lot of curve. You seen alpha particles. You seen all the others, but except for those straight lines a lot. I don't know if you saw them, but here's my 4th experiment, and it was a success too. So I hope you liked the 4th experiment. And this is Kayla Jones, and I will be back to do another experiment.